All right, 2.4, solving quadratics by using the quadratic formula. So we've talked about just solving by taking the square root. We've talked about solving by factoring. We've talked about solving by completing the square. Those all work some of the time. Square root works if it's already written as a perfect square. Factoring works if it's a factorable, if it's a factorable quadratic equation. And completing the square can always work, but sometimes it just gets real messy. So what we can do as well is we can use the quadratic formula. So that's a nice formula we're going to learn today. You've probably seen it before. That will help us solve any and every quadratic equation, regardless whether it's factorable or in the right form. We can always get it into what we call standard form. Let me talk about that real quick. Standard form is ax squared plus bx plus c equals 0. So we can get it to standard form, and then we can use quadratic formula. Okay, before we talk about the quadratic formula, I'm going to tell you this story, because if you can remember this story, you can remember the quadratic formula. Here it goes. There once was an emo boy. I'm going to represent emo boy as a negative b, who wasn't sure whether or not, I'm going to do whether or not as the plus and minus, to go to this radical party, that's my radical sign, or b squared and miss out on 4 awesome chicks, b squared minus 4ac. This is what I call my discriminant. We'll talk about that in a little bit. And the party was all over at 2 a.m. Over 2a. Okay, so let's do it one more time. There once was an emo boy who wasn't sure whether or not to go to this radical party, or b squared and miss out on 4 awesome chicks, and the party was all over at 2 a.m. Okay, we got this story down. Let's put it all together. So this means x equals, there once was a pessimistic boy who wasn't sure whether or not to go to this radical party, or b squared and miss out on 4 awesome chicks, and the party was all over at 2 a.m. If I put that all together, here's my formula. There once was an emo boy who wasn't sure whether or not to go to this radical party, or b squared and miss out on 4 awesome chicks, and the party was all over at 2 a.m. Okay, what this means is, if we're in standard form, as I have written right here, except for a slight typo, there should be an X right there. If we're in standard form, then we can just take our A value, B value, and C value and plug it into this equation, and that'll give our solutions for X. So we found the solutions other ways. This is kind of a longer way of doing it, but sometimes we have to do it this way because we can't do it the other ways. Now, just a little hint. I'm going to do this by always finding the discriminant first. That's the b squared minus 4ac. That's the part, if you look over here, that's the part underneath the square root. I'm going to always find that value first. So let's do that first. Let's find b squared minus 4ac. Let's just plug those parts in. Well, my b is 9, so I got 9 squared, minus 4 times my a value is 7 times my c value is negative 5. Okay, 9 squared is 81. And negative 4 times 7 times negative 5 is 140, and it's a positive 140, so we're going to add 140 here. Okay, if I add those two things together, I get 221. All right, so my b squared minus 4ac is 221. Now, let's rewrite the quadratic formula. It says negative b plus or minus the square root. And I should be going through the story here. There once was an emo boy who wasn't sure whether or not to go to this radical party, or b squared and miss out on 4 awesome chicks, and the party was all over at 2 a.m. Okay. Well, look. Negative b, I have that. I know what my b value is. It's 9, so I'm just going to write negative 9 plus or minus the square root. And this whole business in here, I already have that as well. It's 221. So 221. And then that is all over at 2 times my a value, which is 7, or 2 a.m. Okay? So now we can simplify this out. Let me zoom in so I have a little bit more space to work with here. And the whole time this is just what x equals. This is my solutions. So I have x equals negative 9 plus or minus the square root of 221 all over 2 times 7, which is 14. Now, at this point, I'm almost done. I just have to see if there's anything that I can reduce out. If there's a number out in front of here and a number here, I want to see if there's something that I could take out of both of those and out of 14. If there is, I need to do that. I need to reduce the fraction. So first we're going to see if we can reduce a square root here. Hopefully you've seen this before. I'm going to just do a little side work. To reduce the square root, I just check and see what multiplies up to 221. Well, there's only two things that multiply up to 221. It's 13 and 17. Neither of these can be factored anymore, and or are they? They're not perfect squares. So I can't simplify this square root. So I'm actually done. This is my answer. So what I want you guys to do is go ahead and try practice number 1. You will be able to simplify that one. So I'll show you how to do that once we get to your answer. But go ahead and just plug these values into the quadratic formula. Remember to do the discriminant first, so the b squared minus 4ac first. If that helps you, you don't have to, but I think it's kind of helpful to do that first. And then you can unpause the video once you've got a solution. Okay, hopefully you did this part, got 120 for your discriminant. Then you plug in all your values, you got negative 8 plus or minus 120 and 4. What I want to say here is this square root 120 can be simplified. So I'm going to show you what I mean. If I have the square root of 120, let's see if I can make a little factor tree here. I can. I know that I could take out a 2, but I think I could also take out a 4. So let's take out a 4. 120 divided by 4 would be 30. So I got 4 and 30. Well, 4 breaks down to 2 and 2. 30 breaks down to 5 and 6 breaks down to 2 and 3. In order to simplify a square root, we're looking for perfect squares. This is a perfect square here, and it breaks down to 2 and 2. These are not perfect squares, so what I like to do is I like to put little boxes around these numbers that are loners. And the way this works is whatever is a perfect square, I can pull out of the square root. So I can pull out the square root of 4, which is 2. So let's just do this. I could write 2 square root and then put all the loners back inside, 5 times 2 times 3. Well, if you simplify this down, you get 2 times 5 times 2 is 10 times 3 is 30. So what I'm saying is that the square root of 120 is the same thing as 2 times square root of 30. And we actually want to do that with these. We want to simplify this. I'm sure this is something you've probably seen before, but I just want to remind you about simplifying square roots. So now, let's rewrite this. I got x equals negative 8 plus or minus, and instead of the square root of 120, I'm going to actually write 2 square root 30. And then that's all over 4. The reason why I wanted to do this is I now can see that I can take a 2 out of everything here. I can take a 2 out of both terms on top and a 2 on the bottom. So that means I can reduce this fraction. So let's take a 2 out of here. That'd give me negative 4. Take a 2 out of here, just give me 1. Take a 2 out of here, give me 2. So we write it. I got x equals negative 4 plus or minus. I don't really need to put the 1 there because it's just a 1 times 30, or square root 30. So I'm just going to put square root 30 and then all over 2. I cannot reduce it any further because there's nothing else that I could take out of this square root, and so there's nothing that I could take out of both terms. Some of the temptation will be, oh, I got a 4 and I got a 2, I can reduce that. But remember, there's kind of imaginary parentheses. So that means if I'm going to do it to 1, I have to do it to both. So if you can't do it to both, then you can't do it at all. So this is as simplified as the answer can be. All right. Okay, so sometimes the equation doesn't start off in standard form. So to arrange them in the correct order first, then use quadratic equation. So let's look at this thing. Okay, well I already have everything on one side, so that's good. If it wasn't, I'd have to do some algebra to get it on the right side. But it's all on the correct side, so now all I have to do is put it in the right order. Well, the right order would be negative 3x squared plus 2x plus 9 equals 0. Notice that the signs stay with the number they're in front of. So the negative stays in front of the 3, the positives stay in front of the 9, and there's nothing in front of this, so that means it's positive as well. All right, I'm ready to go ahead and use the quadratic formula. I'm always going to do the discriminant first, b squared minus 4ac. My b here is 2, so 2 squared minus 4 times a, which is also negative 3, times c, which is 9. So I get a 4, and negative 3 times negative 4 is positive 12, and 12 times 9 is 108, so this is really 4 plus 108. And that's 112. So my b squared minus 4ac is 112. Let's go to the actual quadratic formula now. Negative b plus or minus the square root of b squared minus 4ac all over 2 times the a value. And remember, this is my solution for x then. So x equals negative 4 plus or minus. I did the discriminant already. B squared minus 4ac is 112. Again, the discriminant is just what's inside the square root. And that's over 2 times my a value, which is 2 times 2, which is 4. Okay, I need to check and see if I can reduce this at all. Remember, if I can reduce this square root, I might be able to reduce this whole fraction. So let's do a little side work. Can I reduce the square root of 112? Well, I think that I could take a 4 out of that. So let's just, in my calculator, I'm just going to do 112 divided by 4, and I see that it's 28. Ooh, I think that I could reduce 28 down. I could take that to 4 and 7. Look, here's my perfect square. It's 4 times 4, or 16. So if I wanted to, I could have started off by just taking out a 16 and a 7. But it doesn't really matter. When I do my factor tree, once I have a pair, I can stop. 7 doesn't factor down anymore, so that's my loner. So I could write this as 4 square root 7. And so I'm going to do that. X equals negative 4 plus or minus. You know what? I made a mistake. I want to make sure you guys see that real quick. This 4 here is supposed to be 2 times my a value. Well, my a value is negative 3, so this shouldn't be a 4. It should be 2 times negative 3, which is negative 6. I bet some of you guys were really happy. Thought maybe you'd get a row back, but I caught it. So 4 rad 7 over negative 6. Okay, the purpose of that is to see that I now have a value that I could take out of both terms on top and the term on bottom, so that means I can reduce. So let's do that. I could take a 2 out of everything, giving me, actually guys, I could take a negative 2 out of everything. So let me explain. If I take a negative 2 out of this, that would become positive 2. If I took a negative 2 out of 4, well, this is already plus or minus, so it doesn't really matter. It's still just 2. And then on the bottom, it's 3. So let's rewrite that, because remember I took a negative 2 out of everything. That's going to give me 2. And I could write this now. I could switch the sign and make it minus plus, but it doesn't really matter. It's still just plus or minus 2 rad 7 all over 3. So now we have our solution. Boom. Okay, so that was a lot of little work there, but we got our answer. So I want you guys to try practice number 2 on your own. Remember to put it in the correct order first, okay? It's got to be in the correct order first, and then you can use the quadratic formula to solve. Go ahead and try that, and then pause the video, and then come back when you're ready. Okay, I got the discriminant was 88. I plugged all that in, and I got 4 plus or minus square root 88, and 2 times negative 9 is negative 18. Again, I'm going to check and see if I can reduce this square root. So let's do a little side work over here, the square root of 88. Well, I think I could definitely take an 8 out of that, and an 11. And out of 8, I know I could take a 4 and a 2, and I know that I could break down 4 to 2 2s. So here's my perfect square. It's 4, and it breaks down to 2 2s. That leaves me with a loner of a 2 and a loner of 11. So that means I can pull a 2 out, square root, 2 times 11, or 2 square root 22. So I'm going to rewrite this. X equals 4 plus or minus 2 rad 22 over negative 18. Now there are numbers that I could take out of both terms as well as the bottom, so that means I can reduce it. So let's do that. I could take a 2 out of everything, leave me with a 2, a 1, and a negative 9. So if I rewrite it, I get x equals 2 plus or minus, I don't need the 1, I could just write rad 22 over negative 9. Okay, that's the last question. However, I'd like for you guys to go ahead, just to prove to me that you've been listening all along and paying attention, I'd like for you to write your last name just to the left of example number 2. Again, that's the last name just to the left of example number 2. You're going to need to do that to get full credit. Thank you.